Predicting buoyancy of objects. So in this example problem, we're given pictures of ice and water molecules. So it says, using the diagram as a reference, which of the following best explains why ice floats on water? So we know that buoyancy has to do with something, whether something sinks or floats. So if in a specific substance, some things will sink and some things will float. If something is less dense than what it is put in, it's going to float. It's going to float. If something is more dense, then it's going to sink. So if it's less dense, it floats. If it's more dense, it sinks. So we have to remember that about density and how it predicts buoyancy. So here it says the molecules in ice are more spread out, so ice is denser than water. So ice is more spread out. Actually, as we can see, the molecules are more spread out than water. They're in a regular arrangement, indicating that they are in solid form, but because of the hydrogen bonds that are in water, it actually helps ice have more spread out molecules, and so making it able to float on water. So we know that if it's denser than water, it's going to sink. So that's not true, because the problem says it floats on water. So A is wrong. Now B says the molecules in ice are more spread out, so ice is less dense than water. Exactly. That's exactly, if it's less dense than water, then it's going to float. And because of the density of ice being less, it's going to float, and that can help us predict the buoyancy, and so B is the answer. Both C and D mention that water is more spread out, the molecules in water are more spread out, which we can see from the picture is not true. So C is out of the running, and so is D. And we have to remember this more dense sinks, less dense floats idea, so that we can understand how density predicts buoyancy. And this is not always the case, that something that's in solid form will float in its liquid form. This is a specific case of ice and water, but we have to understand that it's because of the density of the objects. That's how we can predict the buoyancy.